In this video, I will present LearnedWMP, which is a learning-based method for predicting the working memory requirements of a batch of queries or a workload. Estimating working memory demands of database queries is important because without accurate estimations of the working memory demands, the database management systems often suboptimally allocate memory for the processing of the database queries, which results in the DBMS underperforming and not achieving optimal throughput. Existing techniques for memory estimations at the DBMS make simplifying assumptions on the underlying data as well as estimates the memory demand of one query at a time. A LearnedWMP model is trained with training workloads where each workload is a batch of queries. LearnedWMP looks into the query execution plan as selected by the query optimizer. From this query execution plan, this query is represented into a vector. Next, queries that have similar characteristics and estimates in the query execution plans are assigned into query templates. Next, these queries in each training workload are represented as a distribution of query templates or a histogram. This distribution of query templates along with their collective actual memory utilization from a sample execution are passed to a learning algorithm such as a deep learning network. At the end of this training phase, the learning algorithm produces a trained model that can predict the memory requirements, that can estimate the memory demand of an unseen workload. Next, I'll take you through a sample execution steps of LearnedWMP. So, from the TPCDS dataset, I have selected a workload. So, this workload I have selected has a collection of 10 queries, and here is the query that I have selected. Next, I will see the query plan, and here is the query plan. In the next step, we generate a vector based on the information that is available in the query execution plan. For example, what kind of operators are found in the query plan and the estimated cardinality in the query execution plan and how many times each operator had appeared in the query plan. From this information, we generate a vector. We run this vector representation of the query plan by a trained model that identifies the query template of this particular query. At the end of this templatizing step, we identify the templates for each of the queries in the training workload. In our sample implementation, we have used k-means clustering algorithm for learning the templates of the queries. In the next step, we generate a histogram that represents this workload. Each bin in this histogram represents the count of query templates that are found in the given input workload. It's not necessary that each workload has a member from query template. We evaluated our LearnedWMP method using 3 database benchmarks, which are TPCDS, Join Order Benchmark or JOB, and TPCC. So as you can see in this picture, we are comparing the average performance of LearnedWMP system against the DBMS. This bar represents the average error made by these two techniques. The smaller the bar, the smaller is the magnitude of the error. As you can see here, LearnedWMP system has had significantly smaller errors as compared to that of the estimations of the DBMS. We have seen similar pattern with the other dataset. As an example, join order benchmark. I just presented LearnedWMP, our novel method for estimating the working memory demands of database workloads in batches. We have demonstrated that LearnedWMP can improve the memory estimation of database workloads significantly as compared to the state-of-the-art practice techniques in database management systems.